Hey, what's up? It's Jake from Nimbus DevOps, and I'm here to talk to you about section 1.10, which will cover classes and objects. So, I had to take a break for a little while after reading through this part of this chapter because my brain started going into meta classes, and I don't think it's something that we need to discuss in this early on. But I do think that discussing classes can be understood by somebody who's never really written any code from the academic sense. So let's talk about this. So the example I'm going to use to describe what is a class is to talk about, because we're going to talk about instantiation. So we're going to have to discuss a couple concepts that you usually don't talk about until much later in the coding process. But I'm not trying to get 5-star reviews on Udemy or whatever in this video. I'm trying to take an inside out approach or upside down approach to going over learning Python through this Pact publication, which is an interesting take on it. So, um, we've kind of talked about objects, right? Like everything is an object in the world and whatnot, and that you know a variable is an object, a function is an object. Um, and so what we're kind of do is we're going to take that another step further and abstract this away a little bit more. So I'm going to start this with an analogy talking about bikes. So you've had a bike or you've ridden a bike or you know somebody who's ridden a bike or had a bike. I've done both of those things. And the best way to describe this, excuse me, is to talk about what is a bike? Can we all define a bike? What are the characteristics of a bike, right? If I just made some file here, bike.py, and I talk about I ask the question, what is a bike, right? And you'd say, well, um, autocomplete fail. I want a bike. So what is a bike? A bike, what are the properties, right? It has two tires, right? It has two tires. Let me do this with a text file so I don't have this autocomplete stuff or markdown or something. Okay, so a bike has two tires, right? What else does it have? It has some sort of the frame material. Maybe it's an aluminum bike. Maybe it's some sort of polycarbonate bike or carbon fiber or something like that. Maybe it has handlebars. You know, it probably has a color, stuff like that. And so we just brainstorm, right? No wrong ideas when you're brainstorming, and we just throw stuff out and go, okay, everybody around the table, can we all agree this is how we're gonna define a bike? And everybody agrees, right? We say, okay, this is what a bike is. Okay, so we defined bike and it has these things, right? So this is how we're going to get into the idea of a class. Okay. Now, you might have a bike. Maybe you own a gray bike. And let's say that we're going to take two people. We'll take Tom and we'll take Sharon. Okay. Now, Tom has a bike, right? Tom has a bike. And Tom's bike is red. Okay. Sharon also has a bike. And her bike is blue. All right. So they're both bikes, right? But we have this idea of what a bike is. And then Tom's bike is just one version of this bike. Sharon's bike is another different version of this bike. Okay. And I should even put in here like the color is red. All right. The color is blue. So what you have is you have the idea of a bike, right? And then you have like an actual bike, and then you have another actual bike, and that could be like Tom's bike or Sharon's bike. So in this case, what we need to get to is something called instantiation. Now, instantiation in itself, we talk about having something that's created. If you think of our bike example as like the template of what a bike can be or should be or how it's defined, each bike is an instance of this bike. It's an instantiation. So Tom's bike is one instance of a bike, whereas Sharon's bike is also a bike, but it's another instance of this bike. And so this is the concept of instantiation. Now, we know everything we need now to understand what a bike is. If somebody says, "I bought a new bike," and we go, "Oh, it must have two tires and a material of a frame, and it has handlebars, and it has a color," and we understand what a bike is, right? So we know the concept of a bike, and we understand that Tom and Sharon have two different types of bikes because they're two different instances of this idea, this concept of what we understand as a bike. Now, this might sound like a way over complication of a very simple thing, and you would be correct in saying that. So, in computer programming, we call this a class. Okay, so they're just used to create objects. So, if I have a class named bike, and I define that class as having a color, and it has, we'll just say that it has a color and it has a frame material. We'll just stick with two things to make this simple. So a class, and this is where we get into objects a little bit more. A class is an object. Okay, so this itself is an object, and that object, as we know, has an ID. It has a type and it has a value, right? So, and we won't talk about IDs, but this type would be like a dictionary, right? And the value would be whatever the color and the material are. And if I were to specifically talk about Tom's bike, then I would have a class bike. And now let's turn this into actual code. I'm going to delete all this. You can rewind if you need to. I'm going to change this file back to a Python file so you can kind of see how the colors change with it. So I'm going to make, let's see, make a bike class. Okay, so I'm going to make a class called bike. I'll even do it with a capital letter. Okay, so what is this? What is this class? What do we need to define? What is a bike? Well, this is in Python. You'd be like, okay, well, I'm going to do this thing that says I'm going to initially define a bike as being itself. It's a bike. It has a color, right? And it has a frame material. Okay, so then where does that come from? Well, whatever itself is, whatever that color is, that's what the color is. And you're probably like, what is he talking about? Well, also, whatever itself is, whatever that frame material is, well, that's going to be our frame material. Okay, and then I'll just leave it at this for now. So I just wrote a class. This is a class, a totally legit class, and we define the bike. What it has a color and a frame material, right? And this might not be totally clear, and that's okay because we're in future sections. I'm going to break down all the simplification of all the easy stuff and then go build it up from there. So I'm also going to say I'm going to define this function called break. Oops, self. and you don't need to know what this means. And then I'm just going to say, hey, print out braking. Okay, so here's my class. Now I have a class. I've defined what a bike is. Okay, so now we need instances of this bike if we want it to actually exist. So let's take a red bike variable, give it an assignment operator, and I'm going to say the red bike is the red bike dot color. Okay. Um, oh, what am I doing? I want to do red bike is the bike class because it's a bike, right? But specifically, we need to pass some things to this function up here at the top where it initializes. I'm going to give it the color is red, right? So the first value is the color, and then the second value will be carbon fiber. There we go. Okay, and then let's make a blue bike, and we'll say I need the bike class because I'm going to make a bike. It's going to be blue, but it's also going to be aluminum. 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 Aluminium. There we go. And there's our blue bike. Okay. So now we're just going to kind of like, let's check out our objects. So each one of these instances is an object, and this class is an object. So we're going to, just like we used, we made a function, we're going to make a class with a function, with two functions in it. And I'm going to say red bike. What is red bike? It's bike, this, with a red color and a carbon fiber material. And I'm going to make a blue bike doing the same thing. So if we want to see that, I should be able to print red bike dot color. And in theory, this will print red, right? And I'm also going to print the red underscore bike dot frame material. And in theory, that should print, what was our frame material? Carbon fiber, right? Well, and specifically carbon fiber, capitalized. Okay, and we could do the same thing for blue, right? So I'm just going to copy this, and we're going to make this blue. We're going to make this blue. And then in this line 19, this should print blue. And this one should print aluminium, right? and if this works, when the code runs, it will read this class and say, oh, I have a class. It's called bike. What's inside of it? Oh, it's just this thing that has a color and a material. And also, you can use this break function if you choose to, but we won't get into that. Which I should probably call bloop. And then we're going to say I'm going to define this red bike and I'm going to define this blue bike. And then I'm going to print out the properties of this object in order to find out whether or not this worked correctly. Okay. And then once it's done, once it prints that out, we want to just stop, right? So we're going to put on our bike brakes. So I'm going to say red bike dot brake. Okay. And then all that should do is, in theory, it should print braking, because that's what it said to do. Because we're not actually calling this. When you say red bike equals bike red carbon fiber, we're not calling brake. This is just the initialization of this class, so we can pass variables to define what the properties of self are in this namespace, right? So what happens if we run this? I don't know. Let's go take a look. So I'm in the example directory. I've got this bike.py. So let's just run python bike.py. And here we go. So we expected it to print red, which it did, carbon fiber, blue, aluminum, and then braking. And it did all those things. So in this case, I'm able to create a red bike and a blue bike, and I can use this class, which is an object that just defines the properties of this object. This object is red. This object is carbon fiber. And it could be anything you want. You could put anything in here. It could be brown or blue or violet sky. It could be whatever you want, right? So the whole idea behind this isn't to learn how to program. It's to learn that a class is just a way of defining something, right? So if I simplify this, I could just say, hey, a class just defines an object, right? More specifically, probably like an object properties, and then an example of that would be making a bike with all the stuff that we did. And then you can use that later and say, let's say you work for a company that sells bikes, and you could say, oh, we had 10 bike sales today, and your owner could say, oh, well, I need to buy more bikes. What's the most popular color? And you could go to your database and it could do a query, or you could you could write a little Python script, right, instead, that just goes and looks at what was sold and says, hey, give me all of the bike colors for everything that was sold today, and it would just return, a list of all those bikes. Or you could say, hey, count all of those and give me that integer, and it would give you the number of that color. Or you could be like, give me all the colors and then tell me the number, and make some sort of bar chart or something like that. And that would be essentially how you would use a class in like a real world scenario. So classes are great for defining objects, especially things like inventory, but you'll find that you can use a class for literally anything. So I definitely recommend um, using functions, but where it comes into play is like, when would you actually use a class? Is like, well, I know I'm gonna make this thing that goes, just in case I need this for later. I'm gonna make a function that goes, not even a function. I'm just gonna write something that says, hey, I'm gonna delete all this. Um, get more complicated. I'm gonna say x. Um, I'll say user input equals input of whatever you say, and I'll give you a prompt that says enter a number, right? And then I'm going to take that input and I'm going to multiply it by 2. That's what I'll do. And then I'll say response equals user input times 2, right? Something like that. But in order to do that, I need to make sure this is an integer, and there's so if you're already familiar with programming, we're not going to do any error handling in here. And then all I'm going to do is I'm just going to print out the response. Okay, so if I save this and I rerun bike, it's going to say enter a number, and I say 4, and it says 44. And it's like, well, that doesn't work very, very well, right? And it's because response equals user input times 2. It's because it's literally saying 4 and 4. It printed out 2 4s. And so I do have to do something. I'm going to make this an integer, and that way it knows that it's a number and will multiply it instead of just write it twice. Now let's try it. Enter a number, 4. All right, and the answer is 8. Cool. So that works. So this isn't even a function. This is just, I'm just typing stuff here. So if I wanted to make this a function, right, I could define this and say define math stuff. Okay, that's going to be my function. And in math stuff, I'm just going to indent this, and this is now my function. And then it's going to take that, and it's going to set a response, and it's going to print a response. So now I just took my exact same code and I turned it from a script into a function. And all I'm going to do is I'm just going to call math stuff like that. And if I save this and I run it again, it does the exact same thing, but it's structured differently. So this whole conversation, these last like 5 videos, is just about structure. So yeah, and I used the saved word. Bad, bad, bad. Let's just make this R. And let me get rid of this. response is something we'll need later. We can use it for something else. All right, so this still works. So I have a function. Great. Well, now let's say I want to encapsulate all these things together into a class. Well, it's easy. I'll just say class will be twos. I'll just call it twos. All right. And inside this class, I'm just going to do the exact same thing. And then and this is in the scope, right? And then outside of this class, I'm going to say, hey, I want you to actually do this, right? So we just need we created an object, right? So if I do this now, watch what happens. Enter number 4. It still prints it. I didn't have to do anything. I didn't have to call anything. I had to do whatever. But I could also define other things in this stuff, right? I could, and what happens if I pull it out of the class? Now it's in a different scope. Then what happens? Look, it's not defined, right? Because it's out of scope. But if I stick it in here, now Python knows what it is because it's inside. So when you're doing this, like I don't need to make a class for this. This is unnecessary, right? I can just leave it as a function with a function call, and that makes sense. But if you had multiple functions and that function had some properties, so maybe math stuff, maybe this was instead of just outputting one number, maybe there was one number and it also told you the type, right? So I could print R, but I might also, like in our bike example, I might want to have like, what type of number or what type of answer is this? Oh, it's like it's an integer. So if that had two values, then I could say, hey, print math stuff type or dot R and math stuff dot type, and I could define that inside of here. And if I needed those properties, those object properties, I could get them using that class construct. And you can absolutely do this inside of a function too. But essentially, these are just like little Tupperware containers, right? So sometimes you need a little container, and then you have the medium container for lunch, and you might have a sandwich and some carrots, but inside that medium container, there's also a little container that has like some peanut butter in it or something like that to dip the carrots in. And then maybe you have a larger container, and in that larger container, you have 10 lunches uh, that all have a sandwich and carrots and a little container with peanut butter in it because you're taking it to a field trip and you need to provide 10 lunches. And so how going to lunch is simple. You could just take a sandwich and carrots, or you could put them in a container. You could put all the medium containers in the back of your car and drive around and let them fly all over the place, and then just hand them out to the kids, and that's no problem, and so you don't have to use a large container. It just depends on how organized you are. And that is what really comes down to for code structure, is how organized is your code. Now, in the world of programming, you want to be that person that takes the large container with the medium containers that has the little container of peanut butter in it, because it makes it easier to move things around. And when the principal says, hey, we're going to do the same thing, we need that large container you brought with all the lunches, can you do 3 more of those? And in programming, I could say, sure, this times 3. And then I don't have to go get 3 more containers and, 30 more medium containers and 30 more small containers. Like I can just repeat and replicate that large container that has all that stuff inside of it already. So that's essentially how it works. If that example is confusing, let me know. But it's hard to try to explain this to somebody who's never coded before, because I wouldn't start day one off with a junior developer coming to work with me to go, okay, let's talk about classes and scopes and namespaces and whatnot. So this whole thing is experimental. and we're just going to try it. So I want to know, if you've never programmed before, does the concept of a class and instances and everything being an object with properties and a class having multiple properties that you can define makes sense? The code doesn't really have to make sense, but if it does make sense, then great. But we'll get to that. I'm just typing it. I pseudocode a little bit for you, but I'm just typing it so you just get used to seeing it. But yeah, let me know if this makes sense or if it doesn't make sense, and we can change it up and add some stuff. But like I said, I'm going through this process of going through this book just to see whether or not this is palatable for people, and I don't know that it is. I don't know that it isn't. Honestly, this is more for me than it is for you. I'm just trying to um, take this different approach to learning Python and see what happens. And if I go back to my original code, the last thing I would tell you is you're probably wondering what in the heck this thing is. So this is just an initializer, and the purpose of an initializer. Let's see if I can how to explain this. Python does some magic to set up the object with some certain values that we pass when we create it. So when we created this, I passed it these values, and when you do this, when it runs it creates this class, but it needs this to be able to do that, and it's just a requirement that you have to pass into there. And so it's anything with these double underscores. When I use the magic word kind of tongue in cheek, but anything that has like leading and trailing double underscores like that really does have something called a magic method, and Python uses them to do this. And so the naming convention is best just left to Python. So you would just include this and then define whatever you need to define after that. Yeah, so I guess that's it. I would say the last thing is, if you remember how there was a set of attributes in the object that's in a namespace, hopefully that's a little bit clearer now, because you can see that like these properties of this object only exist inside of the class, right? So this would be like a namespace. And if I tried to do something outside of here, it wouldn't know what that was unless I said, hey, go to bike and get the color, right? Because this is using this class. Go to red bike and grab the color. But if I said go to green bike and add the color, it's not going to know what that is. Even if even though there is a color and a green bike is a bike, if I don't establish this here and define green bike as using the bike class with the self.color attribute of green, then it won't know what that is. So inside of that namespace, there's definitions to those things. But outside of it, if it's not defined, it doesn't know what that means. So anyways, yeah, if you have any questions, let me know. And just remember the concept of containers going on the lunch field trip, and that it goes, class and then function, and then under that just a module. You're just typing it without even defining it, and it works just fine. You saw I was able to multiply 4 times 2, and I did it with a function, and I did it with a class, and I did it without a function or a class, and it works just fine. So it just depends on how you want to organize your code. So just kind of stick that in the back of your brain and go, okay, I understand there's different ways to do this, and move forward. And I'll give you a couple little guides to writing good code, and then we'll get into the real part of this. Well, I'll talk a little bit about the culture too, and then we'll get into the real part of this where we start just going with data types and stuff like that. So yeah, good luck, have fun, and I hope your brain doesn't hurt too much.